Calculus is AP Calculus Lesson 3-6. We are talking about the analytic analysis today, where F is increasing, F is decreasing, and F is having critical values. So our guide, where are we? We are right here on 3-6. 3-6 means that we are finally hitting our analytic analysis standard I, and then we're done in 3 lessons. Then we're going to do some self-checks, pre-tests, and fix-up. We know the deal. So F prime test. So now we're actually doing the first derivative test. So you can either pronounce this the first derivative test or the F prime test. There are 4 steps. We will add on to this in our next unit, or next lesson, sorry, on 3-7. So our 4 easy steps are as follows. Draw the x-axis. Step 2, find CVs. CVs stand for what?
Critical values.
And where do you find critical values? What is the definition of critical value?
Zero or
Where what is 0 does not exist?
F prime.
F prime, yes. So let's write that in the notes too, just in case you need them. So in parentheses here, I'm going to do this in green because I don't ever use green. So in parentheses, if you don't know what that is, that's where F prime is equal to 0 or D and E. All right, step 3, you need to test some points. This seems like I'm talking nonsense right now, but once we actually start implementing these steps, it will become much clearer. And then step 4, you need to have your conclusion.
When you make conclusion.
You need to find the CVs where F is increasing and F decreasing. You need to say where those intervals are. All right, so I didn't really ask this question as well as I could have, but I'm gonna, this is gonna be a note for Mr. Sinodal in the future, so don't write this down, is to find CV, F increasing, F decreasing. I'll have better instructions next time, but that's what we're trying to find. We're finding the critical values, the increasing and decreasing. Increasing, what does that mean? F increasing? Do we know the definition yet?
When the height is bigger than 0? On the graph of F.
No, that's not quite right.
No. Is it F? Just F, not F prime?
Hold on.
We did this at some point.
We did this in 3-2. Yeah, you should know this. F increasing. Definition. I need it. I needs it. Go back to your notes if you don't have it. It's 3-2. Definition of F increasing.
Oh. Whenever F prime is greater than 0.
F prime is greater than 0. And F decreasing, Rochelle?
When F prime is less than 0.
I'm going to do it on the side notes, and you should do it as well because we forgot. That always needs to be on the tip of our tongue. Once we start doing speed sheets, and we should have done one last unit, we should definitely do one for this unit. Speed sheets are a way of saying this is a definition that you need to memorize. I will write F increasing, you will write F prime is greater than 0. And there's a bunch of terms on that, all the terms that you have to have at the tip of your tongue. Okay, so we're on example 1. I already did the derivative for you. Oh, Mr. Sindel, you're so nice, thank you. I didn't know that the derivative of whatever easy function was negative 3x, but you're welcome. Okay, so we took the derivative. We're going to draw the x-axis. And I'm going to draw the x-axis down here because we're going to do some work up here. Actually, I can just draw it up on the top. That's fine. So go ahead, and if you want a ruler, there are rulers up at front, or you can just kind of sketch a line. Give some space because we're going to do some analysis with this line. So there's my line, my x-axis. And we don't need to do a y-axis because we're actually going to be testing some points. All right, so I'm going to label this x. I'm going to make this black to make it look nice. There is our x-axis. We did step 1. Step 2 is we need to find our critical values. So I need to do what to find my critical values again? CV is where what happens?
When F prime equals 0.
Yeah, F prime equals 0. So this thing right here is now 0. So here we go. 0 is equal to negative 3x. Therefore, x is what? 0. Yeah, it's that easy. Whenever you have a D and E, the only thing that can give you a D and E is when the denominator is what? 0. So be careful of fractions. Fractions will give you a D and E, and the numerators will always give you something equal to 0. So just think about that. All right, so we have our critical value. Our critical value is x equals 0. Go ahead and say right there, x is equal to 0. Boom. I mean, I don't need to say x equals 0 because this is a graph of x. So that is a point on the x-axis. And I'm going to label that with what that was. Was that an f increasing? Was that a max? Was that a min? Was that a CV? What the heck was that thing? It was a critical value. Call it a CV. Label it on the top. All right. We found the critical value. Done. We need to find where f is increasing, where f is decreasing. How are we going to do that? Step 3.
Test points.
Yeah, you're going to test points on the left and the right. So what's the point that I should test over here?
-2.
Yeah, sure, -2. When I plug in -2 to this function, I'm always plugging into the derivative, and I'm going to put that in the notes up here that you should write this as well. I'm going to do these notes in orange, sure. Green. I don't know what my colors mean anymore. Test points in f prime. Don't test them into f if you were given f, because that will super mess you up. All right, so I'm going to plug in -2, and you don't need to write down your test point if you don't want. I'm just going to write it here for the sake of the notes. I'm going to plug in -2 into f prime. When I plug that in, I get what?
6.
Positive 6, and that's the key, right? It's going to be a positive number. So this is the thing that you do need to write down. It's a positive. When I plug in -2, and in fact, it would be really cool if I could. Let's see how well I know how to use this program. Oh.
Why do you have to put positive?
Because that's the only important information.
We only care if it's positive or negative. We only care about the sign, because we only care if it's f prime is greater than 0 or f prime is less than 0, because we're trying to find increasing and decreasing. So we only care about the sign, which means I'm going to come back here. I want to move this down a little bit, just so that my notes look better. When I plugged in -2, I got a positive. Therefore, on the top, I'm going to label this whole side, which goes out to -infinity, as what? One of these two.
Increasing.
F increasing, right?
Yes.
F increasing, perfect. Let's plug in a point on the right. Arrow, you can do this one because Rochelle chose -2. What point should we plug in? The easiest possible number to plug in is, yeah, let's plug in 1. When I plug in 1 into f prime, what do I get out, Rochelle?
A negative?
A negative. And therefore, arrow, this is what over here on the right? Actually, yeah, f increasing. F decreasing, sorry. F decreasing. Boom, done. We have our answer all embedded on this x-axis. Now we need to actually answer the question that I forgot to actually ask, which is, where are the FCVs? Where are the critical values? And where were they?
0.
Where x was equal to 0, right? Yeah.
Wait, that's just the definition. Oh, yeah,
Yep. Because you could say y is equal to 0, x equals 0. I don't know if you're in the z dimension, z is equal to 0.
Well, the definition for f of critical value when x equals can it be other than 0?
fine.
It can be other than 0 if you have a different type of function.
Because, yeah,
Like,
when you plug it in.
We'll see an example down here. That's a perfect question, yeah. Where was f increasing? This is going to be an interval. You can either do inequality notation or you can do interval notation. Where was it increasing? What is my interval?
from -infinity to 0.
-infinity to 0. So you can write it like that, or you can say x is less than 0. Both of those are fine. And I ran out of room here, so I'm going to write it. I guess I can write it here. F increasing, so I have decreasing next. F decreasing. I'm going to pause here to make sure that we're all caught up. And we're caught up. Okay, interval. So Rochelle just did the last one. Arrow, you can do this one.
0 to positive
Positive infinity, perfect. And then Rochelle, can you give me the inequality notation after you write down that first notation?
X is greater than 0.
X is greater than 0. Bada boom, bada done. Okay, so we're on to example number 2.
Is that just what the homework is too?
Yep, over and over again. So you're not actually graphing it neatly, or yeah, you don't need to actually make a graph where you have an x and a y-axis and say, oh, it looks like blah, 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 like that. You are just finding where it's increasing, where it's decreasing, where the critical values are.
That's why I thought,
All right. Oh, Mr. Sindel, you're so nice. You gave us the derivative again. You're welcome. There's the derivative, negative x squared plus 4. All right. What do I do?
You're gonna fool us by not giving
you draw the line.
Yes, that's the first step. Draw the x-axis. And make sure that you give some room up on top because we need to label if it's increasing, decreasing, or the critical values. And next, I'm going to do what?
You set the f prime of x to 0.
And why do you do that?
Because that'll give you the critical value.
Exactly, yep. So I'm going to say 0 now is equal to negative x squared plus 4. All right, Rochelle, you're up. What am I going to do?
You've tried to find the critical values,
Which are what?
which is
And you can tell me the process, or you can just tell me the answer. Like, what do you do to both sides? Or if you just did it in your head and you can tell me the answer, that works too. Whatever you want to do.
It would be 4, wouldn't it?
No.
Not quite. So let's go ahead and let's add x squared to both sides. So I now have x squared is equal to 4.
Oh,
And then I'm going to do what to both sides, Rochelle?
What did you do with the
you
negative?
square root.
Oh, I added x squared to both sides.
Yeah.
Square root, and then I'm left with x is equal to what?
2.
Careful.
Oh, positive or negative 2.
Yeah, there it is. Because whenever you square root, you always have to have the plus or minus unless it's outside of your domain. We will be encountering some domain problems with square roots, with natural logs, stuff like that. But always assume plus or minus unless there's some weird domain restrictions. So yeah, plus or minus. And if you need that on the side notes, you can write square root always has plus or minus, something like that. All right, perfect. So we have our two values. Let's go ahead and graph them. Boom, boom, there they are. We have a negative 2 there. We have a positive 2 there. What do I do?
Test points.
Test points. Which point should I test?
3.
And I didn't give myself enough room again. Dang it. You're testing 3 because that's going to be the farthest to the right. And I will go ahead and do that. So I'm going to test 3 here. I should probably do this in a different color to let you know that I'm testing points here. I'm going to just choose orange. So I'm going to test 3. And when I plug in 3 into the derivative, Rochelle, what type of number am I going to get out? A positive, negative, or a 0? It should not be a 0 because that will be that one, but
So it would be negative 9 plus 4 equals negative.
negative. So all that side is negative, therefore arrow. This is what for this area over here?
Decreasing.
F decreasing.
Decreasing.
Yeah, there we go. All right, now we're going to switch roles. So arrow tested a number. Now Rochelle's going to test a number. What number are we going to test? Somewhere here or somewhere here?
Negative 1,
Negative 1, where does that go? Middle or left?
middle.
Middle, okay. When I plug in negative 1, I get what? A positive, negative, or what?
A
Positive.
Positive. And then Rochelle, is that going to be what type of interval right here?
FD increasing.
F increasing, there we go. All right. A number over here, what should I plug in? Anyone, free game.
Negative 3.
Negative 3. When I plug in negative 3, what is it? Negative, positive, or, yeah, it shouldn't be 0, so it's either negative or positive.
It's negative.
Is it negative? It is negative. Do you know how I know? I know the shortcut. And I don't know if I should be teaching you the shortcut this early, but I think I'm just going to so you can get it.
All this stuff is shortcuts anyway. It's not like you're teaching us proofs. So
That is a good point. I might as well just teach it then. Yeah, so the shortcut. This number is an even number. Because it is an even number, it's going to switch over each of these critical values.
oh,
If it was an odd number, then it's not going to switch. It's going to stay the same. Eventually, you'll be seeing that shortcut a lot more, but yeah, if this was an even number, then it should switch over each of them. So yeah, that's negative, and therefore this interval is
F decreasing.
F decreasing. All right, so our unanswered question is, what are my F critical values? Where are my F increasing? Where are my F decreasing? I think I might have wrote those out of order, but that's okay because those are the same 3 questions I'm going to ask over and over again. So Rochelle, where are my critical values?
When x equals to negative 2 and 2.
Negative 2 and 2, yep. And arrow, where is F increasing? I want both the interval notation and the inequality notation.
or negative 2, 2. That was very confusing.
Oops. And what should I have here? Should I have a parenthesis or should I have a square bracket?
Probably parentheses.
Why would you say parentheses?
Because it's not including the 2 is the point of change.
Yeah.
Which means not
So at this negative 2, what was the value? Was it positive, negative, or 0?
0.
0. And therefore it's not increasing because it's not positive. Well said. And do the inequality notation. This one is the hard question.
It could be x is greater than -2, x is less than 2, but you gotta write it out.
Yeah, you do have to write it fancy. So I will show you the fancy shortcut-y way of writing it.
Oh,
I'm
would
gonna,
it be -2 is less than x, and then less than 2?
Yes.
Yep, like that. You're saying it all in the correct order chronologically. I did it kind of the shortcutty way of kind of separating those two and putting an x in between with the correct inequality notations. Cool. All right, Rochelle, you're up. F decreasing, give me the interval notation and the inequality notation.
-infinity to -2, union 2 to infinity.
Like so? All right, and the hard part now, inequality notation.
It would be would this one have a union as well?
It would, yes.
So would it be x is less than -2, union 2 is greater than x, or x is less than 2?
X is
Greater than 2.
greater than 2. Yeah, there you go. Perfect. Well said. Cool, cool, cool. And our final, third example, a little bit harder. All right.
Can you give it to us?
Oh, no, I'm going to make it hard. All right. What am I going to do?
Well, it'll be easier now because we can,
You are the boss. Tell me what to do.
Draw the x-axis.
or you find the derivatives first.
You can do either one. I'm going to go ahead and just draw the x-axis because that is step one. There is my arrows. I'm labeling that. That is my x. And arrow has our next step, which is trying to find the critical values. And to find those, my first step is to find the derivative. So what is the derivative, arrow?
3x squared plus 4x.
Wouldn't it be 1x squared?
Oh, would it? Yes, it would be.
And why is that, arrow, now that Rochelle caught it?
3 divided by 3 is 1.
Yep. So that just turns into a 1 right there. Very nice. And what do I do next, Rochelle?
You find the critical values.
Okay, so what am I going to do?
You plug in 0 to x.
0
or
into...
f prime.
Yep.
So then it would be
Okay, and free game. Anyone, what do I do? How do I solve for x?
you try to get x by itself.
Yep, how do I do that?
Would you subtract x squared to both first?
So,
Or you could subtract. Wait, never mind. Either way.
Because if you get x squared to the other side, you would be able to divide at least x to both.
Yeah, but then
you can never divide by x unless you know for a fact that x is not 0. Because if you're dividing by x, you might accidentally be dividing by 0, and that is a sin. You're going to get crucified on the math crucifix. Never divide by x. But good idea. It's just you're not allowed to do it. And you'll get hung or crucified or something bad.
It's funny that you say that because I had one math teacher who would like put the 10 Commandments, but like as math
Oh, really?
words on their door, and that was one of them. They shall not divide by 0.
Oh, I need to have that then. Okay, that's really cool. Yeah, it is a commandment. Don't divide by 0, and x might be 0, so you can't divide by x. What am I going to do then?
It's true.
I hear Ben shouting at his computer.
Yeah.
Do this! It's so easy! It's not easy if you haven't seen it before. What am I going to do? I'll give you a hint. Factor.
Oh. Factor
So
of
would
x.
it be x
Times what?
times x plus 4?
There it is. And now we can use a certain property known as the... It's called the... It's called the zero...
Product property?
There it is, zero product property. Zero product property says this is equal to 0 or this is equal to 0 or both. And we assume they're both, hint, hint, in mathematics. So I'm going to say now x equals 0 or x plus 4 is equal to 0. Therefore, x is equal to -4. -4 is 0, yeah. So we found our critical values. Let's go ahead and graph those. Boom, boom, -4, 0. Notice that my number line is the easiest possible number line. I don't go, okay, there's -1, there's -2, there's -3, there's -4, there's You just graph the two values, you're done. This is just a tool to help you figure out where your intervals are increasing and decreasing. Your tool should be easy to use. Batman has a really easy time with his tool belt. They just fly out. Ours should also be easy. All right. Test values, any values. What values am I going to test for? Something on the left over here. What's a good value to test?
-6.
Let's choose the smallest possible value because we're going to have a cube here.
-5.
Yeah, negative.
Wait, we don't have a cube. It's the
Oh, it's, let's just do -6 because she did say that. I'm sorry. You caught a teacher error. Please log it in your extra credit tracker. That is 1 extra credit point. I am not plugging in fx. In fact, that's exactly what I told us not to do. Maybe I said that on purpose so you would catch it. Yes, we're plugging it into this equation, this f prime equation. Don't make that mistake. So when I plug in -6 as Rochelle's plugging in, am I going to get a positive or a negative? Positive is a thumbs up, negative is a thumbs down. Let's see what they vote.
Wait, actually, wait, yeah, no positive problem. Never mind.
It is a positive. Yeah, so I'm going to put a positive down here. And therefore, this interval is, someone shouted out?
Increasing.
Something increasing?
F increasing.
F increasing, there it is. All right. What is the easiest value to plug in between -4 and 0, would we say?
1.
Yeah, -1 is a really good value. I always feel like I want to write -1 right there, but -1 is in between -4 and 0, so that's what I'm saying here. And when I plug in -1, what am I going to get, a positive or a negative?
Positive.
Negative.
Is it a positive or a negative? We both have different answers. You need to come to an agreement.
Oh, it's negative.
It is negative, yep. And therefore, this interval is
F decreasing.
Yes.
f decreasing, because, yeah, a negative f prime means f decreasing. All right. And finally, what's a good value to plug in over here?
1.
Yeah, 1. When I plug in 1, I get a positive or a negative.
Positive.
Are you sure?
Yes.
I'm also sure. You only have positive things in here, too. Which means your interval is
F increasing.
f increasing, yeah. Cool. So our 3 questions that I should have written down for us because it would have moved us faster. Where are f critical values? Oh my god, the lag here. Critical values. Where is f increasing? Where is f decreasing?
-4 and 0.
So x is equal to -4 and 0. Do try to list these in the correct order. If I said 0, -4, that would be slightly off. I mean, you have the answer correct, but I do have a preference on having them in the correct order.
Is it a pet peeve?
It is a pet peeve. I can't speak right now, but I'm not. I can never take off points.
But it's also like how you put the x squared before the 4x because it's a
Higher degree,
value or whatever.
yeah. And again, yeah, you write it that way. If I say to write it in, I don't even remember what that's called. There's a term. I need to review my algebra 2, but I think it's actually in algebra 1 that you first touch on that. But anyway,
Yeah, algebra 1 must be because I did that before.
yeah.
Algebra 2 that I didn't take, so.
F is increasing. Donde? I can scroll up here.
From negative infinity to negative 4.
From -infinity to -4, so that's 4 union with.
Forgot negative.
1 and 4.
Negative 4. No,
Oh.
no, no. There you go.
Yeah.
Now it's 0 to infinity.
0 to infinity. All right, and I need the interval or inequality notation. That was our interval notation.
X is less than -4 union. X is greater than 0.
There it is.
You could still write it in the other format but without the union.
You could, I think,
The things would just be pointing like opposite directions.
yes. So you can say x needs to be now less than -4, and x also needs to be greater than 0. So I think that's the other way of writing it. I don't, yeah, I need to review my basic math because I always assumed that this was an intersection,
'Cause
not a
I feel
union.
I feel like it kind of includes -4 and 0.
But if you look
Between
at
them.
it, you can still get the information from it.
Yeah. So if you write it both of those ways, I think I'll give you the points. I need to check if this one is okay or not. So let me make a note. Is this okay, Mr. Sindel? And when I see this next year, I'll actually review that before I go over the notes. All right, and f decreasing, where is that arrow? You're up.
-4 to 0.
-4 to 0. And inequality notation?
X is greater than 4. X is greater than -4
And less than 0. There it is. Done, done, done. That's the end of the notes. Are there any questions before we write our summaries? All right, say goodbye to Ben.
Goodbye, Ben.
I don't know if you could hear that, but she basically
No,
said,
you probably
goodbye,
can't.
Ben.
Still
All right, bye, Ben.